The third factor influencing the acceleration due to gravity is the altitude or the height of any place. The acceleration due to gravity decreases as we move away from the surface of the earth. As we move to higher altitudes, the acceleration due to gravity decreases. Let us see this, in what fashion it decreases. On the surface of the earth, the acceleration due to gravity g equals gm by r square. For any distance r greater than capital R, the acceleration due to gravity g dash is given as gm by r square, where this r is the distance from the center of the earth. For a height h above the surface of the earth, small r is equal to r plus h. Then gh is equal to gm by r plus h whole square. Gm can be replaced with gr square. Therefore, it is gr square by r plus h whole square, or g bracket r by r plus h whole square. This is valid for all heights. If the height is very small, this can be approximated as gh is equal to g bracket 1 minus 2h by r. This we'll consider after some time. Now, let us take certain problems which I have given in the form of a table so that we can understand how the things are changing with height. Suppose the height is 0. That means the body is on the surface of the earth. So what is distance from the center? R plus 0 is r. The acceleration due to gravity gh is equal to g bracket r by r plus 0 whole square. That becomes 1, so it becomes g. Since acceleration due to gravity is not changing, the weight of the body is also not changing. Suppose we have got a simple pendulum on the surface of the earth. Suppose its time period is t, which is 2 pi under root L by g. Now let us consider a point which is at a height h, which is at a height r above the surface of the earth. Then the distance from the center is 2r. The acceleration due to gravity is g bracket r by 2r whole square, that is g by 4. Since g has become 1/4, the weight also becomes 1/4. Since g has become 1/4, the time period will become double. Now let us consider height is equal to 2r, then the distance from the center will be 3r, acceleration due to gravity is g by 9, weight is equal to w by 9, time period is 3t. Now you will be understanding here how I am telling so fast. I will tell you the secret. Here you see whatever number is given, add 1 to that. You square and inverse it, that will be acceleration due to gravity. Whatever is the acceleration due to gravity, that will be the weight corresponding. Okay, then whatever number you find here, that number you have to take in time period. Let us see this. Suppose the height is 4r, distance from the center is 5r, so time period is 5t. Acceleration due to gravity is g by 25, weight is also w by 25. Suppose the height is 9r, distance from the center is 10r, 9 plus 1, so time period is 10t. Acceleration due to gravity g by 10 square, that is g by 100, weight is also w by 100. Now here you will be wondering whether it works only for whole numbers. No, it is valid even for fractions also. Let us take one fraction. Height is equal to half radius or 0.5 radius. Then distance from the center is 1.5 or 3 by 2r. What can be the acceleration due to gravity? Square this number, 9 by 4, inverse it. So it will become 4 by 9g. For weight also same number, 4 by 9g. For time period you have to take this number, 3t by 2. Suppose the height is 0.414 r. Then the distance from the center is 1.414 r. 1.414 is equal to root 2. So here it is root 2 now. So acceleration due to gravity will be g by 2. Square it and take it in the denominator. Whatever is the change in the acceleration due to gravity, similar change you can find in weight. Then what about the time period? Here it is root 2. In time period also you get root 2. Suppose the height from the surface is 0.732 r, then total distance from the center 1.732 r. So that's equal to root 3 r. Acceleration due to gravity, you square it and take in the denominator g by 3. Weight is also w by 3. What about the time period? Root 3 times t.